All right, good day, everyone. Today we're going to be talking about our next lesson, which is lesson 2-1. We're going to slightly shift from solving absolute value equations, and now we're going to get into graphing two variable equations, okay? We'll get into more concepts about what a two variable equation is. Excuse me. But the big thing we want to look at today is our learning targets, which are we want to be able to write an equation in two variables to represent a relationship between quantities, as well as be able to graph equations on a coordinate axis with labels and scales. So let's go ahead and start discussing. I already have a few things highlighted for us just to make this video move along a little bit quicker. But if we kind of look at this certain word problem in front of us, we have Roy recently won a trivia contest. The prize was a 5-day trip to New York City, including a round trip airplane ticket and $3,000 in cash. The money will pay the cost of the hotel room, meals, entertainment, and incidentals. To prepare for his trip, Roy gathered this information. Okay, so a couple of key pieces of information here that are highlighted, but once again, let's read through it. A hotel room in New York City costs $310 per night, and the trip can include staying 5 nights. So if you notice, I have both the 5 nights and the $310 per day or per night put on there. The next important piece of information is a taxi between New York City and LaGuardia Airport will cost $45 each way. So if you notice, I have that written right there. So we have a $45 taxi each way. And last but not least, we have $3,000 in cash. Okay? So here's kind of the key thing. In number one, how much money will Roy have available to spend on performances and meals and any other expenses that might arise after paying for his hotel and taxis? Show your work. So let's just discuss this real quick. Let's use what we know to help us try to figure out basically how much money does he have to actually spend in New York City. Okay? To do this, we have to understand that first and foremost, we have $3,000 total. Okay? We have $3,000 total. And anytime you have a total, we're going to be taking money away based on how much we have to spend. So whatever we have to subtract from that. Now, the first key thing we have to understand is the 5 nights a week and the $300 per night go hand in hand, right? If I stay at a hotel for 5 nights, I'm paying $310 for each night. So I want to try to figure out the cost of that. So really, I have to do 5 times $310. Right? Whatever that comes out to be is how much money I'm spending for that hotel room for that week. In this case, just to rewrite it, this comes out to be 3,000 minus 5 times 310 comes out to be 1,550. Okay? Now, there's one last piece of information we need. At the same time, we have to be able to get to the airport and to the hotel, okay, and they said it takes $45 a taxi each way. So the second thing we're going to subtract is 2 times 45, because it's $45 per taxi, and since you have to take 2 of them, one to the destination, one away from the destination, that would come out to be $90. So now we have this equation set up. Now we want to figure out how much money do we actually have. Well, if you really think about this, all we have to do is plug this information into the calculator, or we could do it in our head. Either way works. And then we come out with a value of 1,360. Okay? That is the amount we have to spend on performances, entertainment, and meals. Okay, that's kind of the key thing here. So after all this is left and said, or all this is done, this is how much we have for meals and entertainment. Okay? So our hotel's paid for, and our taxis are paid for. Let's start getting into what else we need. So this next piece of information is important. During his trip to New York City, Roy wants to spend only his winnings from the contest. Okay, so he doesn't want to spend any of his own money. Okay, that's the pointless. You don't want to win a contest and have to go spend your own money. Okay, so he wants to focus on 2 of his favorite pastimes: attending theater, musical performances, and dining in restaurants. After surfing the web, Roy determines the following facts. First and foremost, on average, a ticket for a performance in New York City costs $100. So any performance, he basically averages it out to be about $100. The second piece of information is he spends about $40 per meal. Okay? Two important pieces of information that we need to have for the rest of this problem. Okay? We have $1,360 left over, and he wants to spend $100 per entertainment or performance he goes and sees, and he wants to spend $40 per meal he goes and eats. So let's go ahead and move on to the next page. And just for reference, I basically have both of those pieces of information written right there. Tickets are $100 per show. Meals are $40 per meal. The last important piece of information is we have $1,360 total. Okay? So let's discuss what we want to do here. Roy wants to know how to purchase each ticket. Roy wants to know how the purchase of each ticket affects his available money. Fill in the table below and plot the points on the grid. Okay? So really, right now, all we're talking about is tickets. We're not talking about meals. We're just talking about tickets. Okay? So the first idea of this chart is just to understand how much does each ticket affect my total amount of money. Well, if I go buy 0 tickets, I still have my $1,360. If I buy 1 ticket, all I have to do is take $100 away, and I'm left with $1,260. This pattern will just continue down the line. I lose another $100, I'm at $1,160. Another $100 is $1,060. And then I just keep this process up until I'm down to, oops, excuse me, I missed something right there. I'm down to that 5th mark, okay? Now, don't be careful of this chart because it actually jumps to 8, 10, and 13, okay? Well, we can't really follow the pattern now that we jump from 5 to an 8. So now we have to figure out, okay, well, how much is 8 tickets going to cost me? Well, 8 tickets comes out to be $800, okay? Which means if I work through this, 8 tickets is actually going to cost me, or I'll have left over $560 because I would take the $1,360 and I would subtract $800 from it. 10 tickets is going to cost me $1,000, okay? Because 10 times 100 is 1,000. So I'm left with $360. And last but not least, 13 tickets. I had $100 a ticket. It's going to cost me $1,300. Well, if I take those two and subtract them, I'm only going to be left with $60 there. From there, I'm just going to plot these points on the chart. So at 0, I have about 306 or 1,360. At 1, I have 1,260. At 2, I have 1,160. At 3, I have 1,060. And then if you kind of notice, each time as you go over, you're just going down about 100 each time. It starts to build a pattern. Now, I don't really need to go through the whole entire graph there. We can kind of see the picture there. If I were to build a line within that, we would have this continuous pattern going through to the bottom of the chart, okay? The big thing we want to talk about is to actually derive those numbers, it was fairly easy, right? We knew that we had $1,360, and then each time we were losing $100. With that, we could build that graph to the right. But we also want to try to investigate that graph itself. We want to know certain things about it. For example, what patterns do we notice? Well, if I'm looking at this chart, obviously I can see it's a line, right? It's a line that's going downward. So if we want to put that, we know that it's a line and it goes downward, right? I'm not increasing each time. With each entertainment or each performance or each ticket I buy, I'm actually decreasing. The next big thing that we want to talk about is why it does that. Okay, what is happening each time in our problem? Okay, because there's sort of a pattern here. I'm not going down by a random amount each time. It's not like each performance is a different cost. It is the same cost each time. So one of the important concepts that we want to talk about is this has a constant, and I write Ooh, I'll actually write it out this first time. It says a constant rate of change. Okay. Constant rate of change. Okay. And that's going to be one of the important pieces from this lesson. All right. We have to try to take into account that having a constant rate of change creates these line-shaped graphs. Okay. If I'm going up or down by the same amount each time, that means each point that I select or the next point that I plot is going to go down or up at that same rate. Okay. This is why it creates a line as it is. All right. This is what we call a linear function. All right. Notice how line, linear, I'll write that out real quick. We have a linear function. Okay. A constant rate of change is going to create that. The easy way to remember that is it literally spells line in the problem. Okay. A line-shaped graph is going to create a linear function, and that is because we have a constant rate of change within the problem. Let's go ahead and continue on. All right. Let's go ahead and skip number 4, and let's jump to number 5. Write a function MT that represents the amount of money that Roy has left after purchasing T tickets. Okay. So now let's have this idea where we don't really have an idea. Okay, we don't really know the exact amount of tickets he buys. Let's say Roy is going to New York and saying, like, I really don't know how many tickets I want. We want to build an equation so that basically at any point, I could figure out, okay, you have this much money remaining. Okay? To do this, we have to understand a couple different points. First off, M of T. This is going to represent the money left over. Okay. Oops. This is going to represent the money that's left over in this problem. All right, that's an important concept to understand. Okay, we're using a notation there. M based on the tickets we buy. Okay, that's what this notation is saying right here. It's the money based on how many tickets we actually buy. Next, they want us to use T to represent tickets. So now we got to try to figure out how do we turn this into an equation, okay? And let's just kind of work through this. Let's try to be logical thinkers here and as we try to solve this problem out. The money left over, M of T, okay? That's always going to be what we have left. That's our answer, right? We're trying to figure out however many tickets we buy, this is how much money is left. Well, to do that now, this is where the actual math and numbers come in. To solve this problem, I got to think, okay, well, how much money did we start with? I had $1,360. Okay. So that's if I attend 0 concerts. So then how do we build off of that? Well, this is where that whole constant rate of change comes into play. This is where it becomes important. I'm going to subtract that from 100 times T because it's $100 per ticket. So notice now, if I put 10 tickets into that problem, well, it will tell me I have $360 left over. Okay, if I actually work it out. If I put 5 tickets into that problem, it will tell me I have $860 left over. All right, see how I can create an equation based off this information? The only real different part of this is just the notation. The money left over, M of T. Okay, it's a little bit different notation than we're used to. And then T is for tickets. Okay. Now from there, let's start to increase kind of what we talk about. Excuse me. Use mathematical terminology to explain what negative 100 or minus 100 and the 1360 represents in your function. Okay. Key thing about this is just we want to talk about with the equation M of T equals 1360 minus 100 T. They want to know basically what the 1300 and the minus 100 represent. Well, pretty straightforward. The 1360 represents the total. How much money do you have in all? And the minus 100 represents cost of ticket, right? I mean, that's the whole idea of it. If we have $1,360 total, the minus 100 is going to be the cost of each ticket that we buy. Lastly, that T in the problem represents the number of actual tickets that we are buying. So notice it's minus 100 times T, okay? Because if we buy 5 tickets, then we have to subtract not $100, but $500 from what we have, all right? In the next portion here, Roy wonders how much his meals will cost after spending his money, okay? So now let's take a completely shift. Let's completely shift this whole problem, okay? Instead of dealing with tickets now, we're just dealing with meals. So if he goes to 0 entertainment and he only attends meals. Well, we basically want to jump right to a problem here, okay? We want to try to figure out a function, the event. So our goal is basically to try to create an equation like we did 2 problems ago, but now we're only dealing with this problem here, this little function. Well, this is going to represent how many meals we have, okay, or how much money we have after we actually go eat those meals. To solve out this equation, it's going to be the same process, however. We take our total, which was $1,360, and we subtract 40 times M. Okay? Notice how it's pretty much the same exact equation. The only difference is, number one, I'm dealing with meals, so it's $40 per meal. And number two, I just changed my variable here. Instead of T to represent tickets, now I use an M to represent the meals. And with that being said, I can create an equation based off of both of these, right? 1360 is our total. If I'm dealing with tickets, I'm subtracting 100 each time. If I'm dealing with meals now, I'm going to subtract 40 each time. Okay. We can go ahead and skip letter B here. We already did a graph like that. Number 9 is going to ask us, what is the rate of change for D of M, including units? Okay. Now, this is where we got to talk about. In the last problem, we discussed what the rate of change was. Okay. We talked about how since a ticket was costing us $100, it was going down $100 each time. So number 9, when we're talking about the rate of change within this problem, this is going to be minus 40. Okay. And that represents minus 40 per meal. Okay. So the rate of change each time is if I buy 3 meals that day, I'm spending $120 because it's $40 per meal. So I have to make sure I subtract that within my problems. Besides that, that's all I got for this lesson. As you can see, we're kind of developing 2 variable equations from here, and we're starting to kind of graph them out and see how things work from there. In our next lesson, we're going to be starting to talk about certain inequalities here. Okay, certain inequalities and how do we actually develop these equations a little bit better for this situation. Okay, make sure you answer the rest of the questions, and if you have any questions, bring them to class tomorrow. Okay, besides that, have a great day, and I will see you in class.